Yay, we're live. Okay, but we'll wait for others for like maybe 10 more minutes and then we'll start with the presentations. I will remove this first. And then so you can see the Hivekind office and doing Penang before. Just post some links.
So when's your last day? When's your last day going?
No, not him. The other one.
Really?
It's already out.
Oh, you're in Germany?
Probably.
Oh, interesting.
He didn't say anything. No sound.
Listen, rookie question. How does one find the link to the online streaming stuff?
It's on meetup.com. I also posted on Slack and I posted on Engineers Mind. It's on our learning channel inside.
Thanks.
Oh, Goy, can you post the YouTube link on Facebook as well, just in case people are there?
Yeah, I can share the YouTube.
Sorry, because I don't have Facebook on this profile on this work computer.
Okay, yeah, I check. Let me check on YouTube. See whether it's up.
Wow. Why don't you take a picture from there, see the screen control panel,
You need computer store.
and then you see it 360 as well.
Yeah.
From there, and then you see part of the room as well.
Finally.
Yeah. Let's wait a minute more and then we'll start. Jose, are you okay? Okay.
So I just got my watch. I didn't set up yet because I actually went all the way to one command to pick it up.
Comfortable?
Yeah. And I was set it up, which means to offer the customer JS me that I'm getting to pick that.
Oh yeah, JavaScript meetup is happening tomorrow.
Yeah. I'm planning to take the JS watch over just because. Yeah. Then I'll be there to insult JavaScript developers.
Well, I will start anyway. Can I borrow a chair? Or a chair. Louis, shall we start? Okay, hello for people in Hivekind and online. This is Ruby Tuesday number 93, and we are meeting up with the Penang Ruby community for their 42nd meetup. And we are doing it again both online and here at the Hivekind office. Ruby Tuesdays is brought to you by Engineers.my, which is why you'll see it in the Engineers.my YouTube channel. And of course, the KL Ruby Brigade and the Penang, I don't know what you call yourselves, Guido. The Penang Ruby group, I guess. Okay. You can find us at rubybrigade.my and Facebook, KLXRB. You probably found us at meetup.com/Ruby Malaysia. For the repositories, like the slides where this is from, you can go to github.com/KLXRB. Invite yourselves at Slack with rubybrigade.my/Slack_invite. We have a bit.ly link as well. And discord.gg, we usually use it for code clinics, for like voice, everyone just talking at the same time. So we're not using that right now, we're just streaming. But if you have any questions and you're on YouTube, just post them and we'll be able to read it. I am Tristan, and I am a software developer here at Hivekind. This is our office. And yes, as just a reminder, if you are posting on YouTube, we might feature your comment, and just note that your profile picture and comment might show up on the screen. It may not, depends on if we remember to show them or not. We have a code of conduct. We are copying or like basically implementing the Ruby code of conduct from the Ruby community that Matt's proposed. So just go to rubylang/hens.english/conduct. And we'll start with our first presentation by Jose and Wayan. Is Wayan going to connect to?
She said she was. I'm not sure.
I haven't seen her though. Oh no, she's there. Okay, sorry. I will. So I will do the clicking around or going. Yeah, it's better that I do the clicking around because I can see the people. So our next presentation will be from Jose and Wayan from Hivekind. They're talking about profiling applications and measuring things and what you want to look for, what their learnings are. And I'll turn you over to Jose and Wayan. Up. Where is move myself? And you'll be sharing your screen, right?
Okay.
You want to turn on your webcam as well and same with Wyatt, or you're fine with not showing yourself? Okay.
Only if I'm not sure myself.
Okay.
All we want to do is just okay, so I actually don't know how to do this because I thought that would have more people present here and
I walk around.
so
This is more than last time, like I said. More than last
yeah,
time.
I know. It's
I
just
didn't
because like I
lie.
would
didn't lie.
yeah, it's just because I would ask like if people have like familiarity with microservice, distributed
Yeah.
tracing.
Microservices.
In the, I hate it, but in the,
Grafana,
in the,
Datadog,
huh?
Datadog,
Later, tell me,
Datadog. No,
tell me,
yeah.
later, okay.
Yeah, so
And you don't have to care about private chat. Don't I won't private chat you.
no. I was just checking. Yeah, so anyway, so I'll be talking about like mostly distributed tracing microservices because it's our use case in our client, but it doesn't necessarily need to be a microservice. You can do on your single application. It doesn't do much of a difference. And for this particular one, I'll be also using Datadog, which is a paid service. I don't really know if you can. There are some service, free service, and I think you can do that with StatsD and Purify and some other library up there, but I'm not familiar. So yeah, so for Datadog in specific, we have this service which is called APM. So if you go here, like on these Datadog documentation, you're gonna get like the
We can see
definition.
what
Yeah, you
you're.
cannot see from here, but if you
Oh,
open
really?
YouTube, you can. Can we open YouTube here?
Ah, okay.
So yeah, I don't want to go like into the particularities of Datadog, explaining APM in itself. What I want to do here is like it's a very practical presentation. So on Datadog, when you have like your application set up, you have like this dashboard, which gives you insight of a lot of metrics on your application. The first ones that you see here is like number of requests that your service or application receive. On the right here, you get like percentile of the latency. And this is where all the fun begins, because you can start monitoring the performance of the application from here. And if you start seeing like the spikes on latency, for example, this is probably where you want to find out a bit more what's going on. Or for example, if you get let's see something a little bit more.
Jose, you have to speak a bit louder.
Bit louder.
Shout.
Where is the microphone?
Let's put the microphone closer. So it becomes an ASMR.
Sit. No, don't. Sit.
This is how we go. Slowly.
Okay, so is this better? Okay.
Yep.
Okay, so from here, this is usually what I use to like verify if my request time is okay. I use the percent use and whatnot. And when you have like these spikes, it's where you wanna like investigate a little bit deeper. There are some other things here that you're gonna see. It's like, for example, how much time your application spends on Ruby code. So for example, these two is Ruby code. These are like how much time it takes on HTTP and some other things like in this case, for example, that I'm using distributed tracing, so I have like also the downstream services. So this is like how much time this dependency here takes on the request.
So you can configure this such that it traces all of the services as it passes on from
Yeah.
one API to another.
That is the idea of distributed tracing. So
One thing though about that graph is that people get confused. It's the percentage of time spent. It's not the actual time on the request.
Yes,
You see the metric
Yes.
is 0 to 100 is the percentage of time spent on each component.
And does it, I mean, let's say a request took like 10 seconds and then request took 2 seconds, that's also 100%, right? That's
Yeah.
your.
Yeah, so it's
So-
how much of that 10 seconds was, how many percent of that 10 seconds was in the first
But
layer?
you have this 10% time spent as your y-axis.
Yes,
So
correct.
you can change it later if you want. If you're interested in what is the slowest request and why is it taking too long?
No,
the
so-
lowest I will show later.
You have other ways to see the actual
Yeah.
time, but this is, I'm mentioning this because that part confuses people. It's the percentage of the request. So if you fix something, you see that all of a sudden one part starts taking longer. It's not that it becomes slower. It just
So that, sorry, since we're asking a question,
Yeah.
what does this mean? Like this is very, like this one, right? What does it mean?
This means that probably you had like a spike somewhere that made something take longer on that time.
Yeah,
So
that layer where the spike starts is the thing that took longer. On that particular time, for whatever reason, it took
Yeah.
longer. Then you see.
which in this case it's a database. So this database had a spike. So this one used to take, for example,
Because your application is not just code,
Right.
it's a whole set of things that is in the.
so for example, so for this one in specific, very hard to
Can you enlarge this and zoom in from here instead? Yeah.
That's what I was trying to do, but
Yeah.
I forgot I had this.
Yeah.
So, Tristan, to give an example, if your code is only code, it doesn't call to anything, it's only Ruby code. It doesn't matter how long it takes, it would always be like 100%.
Yeah.
The request for 10 that took 10 seconds, the one that took 2 seconds would be 100% of the Ruby.
Not right.
Happened to your graph.
I forgot.
We've been there.
It's the past 1 minute, so you have to adjust the range.
Yep. I saw that.
I think we have YN for backup. I said it.
I'm just looking out for him.
Can you trace that each function is causing problem?
Yep, I will do that.
Okay, we'll do that right. Cool.
So Iman already has ideas.
No, because I do profiling, sit for 10 years, 5 years, be
Yeah.
there through that.
So there you go. So this database usually takes 1%. On this particular time here, it took like 20%. So this is where this particular spike that you saw. So it makes like, okay, so if my Ruby code was taking 90%, now it takes less because this one spiked. And you see the compression here. Because at this point it's 33%. 33, but usually it's 48 to 50%.
So usually bulk of the time spent was in Ruby
Yeah.
code, but now a lot.
Because it's what Carlos pointed out because it's a percentage. So if like it's not seconds, so here like if my database used to take 1%, I takes 20 to 20%. I mean to those 19% of something else. So
It's very non-intuitive.
Yeah.
The person. No, because so if you have, for example, 2 seconds, right?
Yeah.
And then your code to the database
Yeah.
starts taking 2 seconds, you see the thing shrinking on the
I
code
mean,
side.
okay, because I already know its percentage.
Right.
Then it makes sense.
Maybe
automatically.
yeah, but
Maybe the better question here is why would you use percentage view?
Because it's the equivalent of ON. The reason we think ON is because we can't calculate all application in second. We can roughly estimate the number of steps. So that's the reason we use N value. So because it's only an estimate.
But this is a timeline, no? So you
Uh,
are
in this
comparing
case,
it from a previous
but-
second.
But if you use a real application, then what you care about is when the application is running, most of the time it's average. Think about average. Then you really want what you care that You let each okay, so time change for different reasons. At one time, at a spike of more user, of course, it will be slower for the same process. So then if you use time all the time, you'll be confused. You will always be confused. Percentage, but on the other hand, normalize the time so that you only care about at this time what is causing it to spike within the process. So that when you have more user, slower application, then you won't be confused with the time itself.
Sorry for derailing you.
Sorry.
It's okay. No, it's good because I am looking for something that I want to show.
Yeah.
So another thing that you were asking is like if these trace requests from downstreams and
Okay.
so this is actually not the best example.
So.
But this is an actual application that you use Datadog for, right? And you managed to fix a few production slowdowns because of this thing that you're doing right now.
Oh no, that's very cool. The one below.
Which one?
No. I don't mind. So what you want to show
Okay,
there?
So yeah, so you also see like a dependency map. This one is actually not cool. There is some. Let me try to find it. Okay, that's the dependency map I wanted. Because from the controller you have, you can go like see like visually what is being called and like in downstreams. And this is like and this is where the distributed tracing comes here with the APM. If you have like a single, even if you have a single application, actually, you still see like database or like mem cache, like some other stuff as well.
These are libraries, right? These libraries that reports, right?
No, these are all, yeah, more or less. So the way Datadog works is that's part of the reason I put it here. So everything you need to do is pretty much add this gem, DD trace.
Okay, I know this.
And what these DD trace do is that like the gems that you use on your application.
Trace is a system tracer. I know what's trace. Never mind. You should explain it because other people may need to know. So,
Yeah. So what this DD trace will do, like it will pick like the most common libraries like Redis, like Rails Active Record and whatnot, and start doing like either adding some instrumentation when it can, or it will do a monkey patch on the most common ones at least. So I mean, DD trace like it's not the case for every library. So for now, we are implementing the similar things for like C applications. So every library we have to add our own because it's not supported like officially.
Yeah.
But Ruby, it is supported officially, so they already like provide like probably like most of the most common gems that people use out there.
But I thought V-trace would be by default supported by application or application.
So DD trace was data.
Yeah, DD trace.
Oh, it's not
yeah,
trace.
yeah,
Okay.
DD trace.
Okay. So
Yeah.
it's not D-trace, the system tracer.
No,
Okay.
Datadog.
Yeah, Datadog.
It's a good point.
I mean, they probably took inspiration from D trace.
But D-trace, the problem is that they provide too many information. It's not too useful for application purposes. And also, you need the knowledge to actually interpret D-trace. Normally,
This I've
No,
never.
it's same with this one. The raw output of the tray is probably not usable.
but they make
Then
it
you have a UI.
processable. That's the important part.
So for here, from here, you're gonna have the well, on this case, I'm checking the rack requests. So I have like the controllers here that I can go deeper. I can do like random craft shows as well. And then you're gonna see like similar things like for latency for different templates and whatnot. But what I want to show here that is
Okay, can you stop for a while? That's resources also show resource use, RAM, disk space, that's up to CPU.
good question. We can check that.
Okay, it's available. It's available.
Yeah. So what we see here is pretty much like similar stuff. Percentage seen, the latency, but now I'm checking like the controller itself. Because that one here that I showed before, it's more like an aggregation of every controller.
Yeah.
And now I'm checking like this controller in specific. And there is, so that's where you get the dependency map.
Dependency map.
And here you're gonna see like across multiple services as well. Probably.
So you installed Datadog on all of these things.
Yeah.
And
Yeah.
it's not just import a DB trace module.
Every application has to have the
Okay.
tracing as well.
So it's not something that you set up in the beginning that it will trace their way up.
No.
Okay. Okay.
Yeah, it's yeah.
And
It-
then,
it
like a
requires
virus,
kind
it's
of
just
a-
a worm.
Yeah, no,
Emails
no, no.
itself to the
No,
next.
no, because here what it does is that the you pass like a request ID throughout.
Okay.
Yeah.
But if one application doesn't have like a way to send those stats to Datadog,
Okay.
that particular application will never show up.
Okay.
So it's just like halfway. It requires like quite a preparation to have like something like this.
You need all the HTTP requests to include the trace ID so that each
Yeah.
application can report the
Exactly.
It's almost like a cookie, but for servers in Datadog.
It's
Kind
more,
of.
Yeah, kind
You
of.
have a way to track.
it's more like probably a middle. It's more like a middleware.
No, it doesn't what do you call this? It
Manipulate.
doesn't manipulate it in the middle though.
Oh, okay. Interesting.
Like it always sends to Datadog that I got this request, and then this is the ID, and then I know this came from there. And it places itself on the.
And here is where I usually use what I use to find out bottlenecks and where to tackle issues. So here is the report of every single request. And here you get the breakdown per request.
Why
So,
does some of them have the bar graphs and the others don't?
I don't know. It's probably because the Datadog didn't receive
Enough.
or it didn't receive the information at all. Because these are all like HTTP requests to Datadog services. So some of them might be lost or something like
I
this.
would guess that it's per sampling, so not every request
Could
triggers
also be the
the
case.
the
Could also
metrics.
be
Because it's going to take.
So you have the overall time, but you won't have the detailed logs.
Yeah, could also be the case.
Difference actually. If you notice the time, right? It's
Yeah.
like a few seconds. It's few seconds change. It doesn't change that much.
Exactly. So before that, I was showing like my spikes on latency. This is where I usually go. Okay, so from the slowest request, what's going on, and then it gives me the breakdown of things happening, and it gives me this flame graph of every operation happening on the application as well. So on this case, I have 1.7 seconds, and 1.23 seconds is spent rendering HTML. And again, because this is a microservice architecture and and whatnot. So during rendering, in this case, we are doing like a lot of HTTP calls as well.
So this is
And
for one
then-
request.
Yeah,
Is it
this is
doing
for
that-
one request.
For one request for that particular, that leaf endpoint. And that means, it goes down through it, and then it gets assembled, and then you get to the next API.
Yeah.
Then it gets assembled again.
Yeah.
Which is why you have this.
Yeah.
Pattern, right?
Yeah. So what is happening here is that we are rendering a collection of objects, and each object has a bunch of like more information to go like back and forth. So think of like a n+1 operation here
Yeah.
that you are doing, like and
And
fetching
you can
things from
only
database.
do the next request depending on the information that was returned to you, and then.
Yep. And this is a collection of objects, so it, like you're going like one by one, like sequentially. So you get like this huge delay here. And based on these, we decided to change a little bit of the architecture for this particular application. So instead of having like these downstream calls, we decided like to do something completely different.
You cache it.
Yeah, to cache, but like it's not really a pre-cache. It's more like we are pre-storing all the data needed in database, and like you just go to that point and you have like the whole object.
Yeah, so
You localize the data.
Yeah, no, I think it's you're assembling, like this fight is like one microservice calling another. And this, like what a microservice architecture would look like, because you're chaining, right? But I guess what happened is you started assembling the data, and so it's one chunk, it's just
Yeah.
one call.
Exactly.
You don't have that chain.
Exactly.
Each layer is another service,
But
so you're chaining down.
Wait. Each layer are not object.
It's a microservice. Like each layer is a microservice.
Oh, each layer-
Each layer is another service.
So
That's
it's
called-
Yeah, each blue span here is a microservice.
So meaning when you go through it, then you can get another request.
Yep.
So it will be, so let's say if you go to one of these service, then this service can review.
Can you zoom in to one of the slides? Like see, it goes down and then like this one.
Okay, so this is so this is your, okay, so each of these are actually HTTP requests.
Yeah. So
That's why
imagine that you have like one object with
Yeah, yeah,
5
yeah.
attributes.
So
Each attribute fetches information from a different endpoint. So you go here, you fetch, you go
Okay.
on the second one, you return.
you're profiling HTTP requests, you're not profiling Rails objects.
Not just
This is
Rails
like
object.
larger
Yeah,
than-
yeah. It's a larger picture because I'm profiling like HTTP request and then like going down on the rabbit hole and then like, okay, so how much of database I'm using and whatnot.
Okay, so you do count that.
But the reason why it looks like an inverted stack is because it comes from here, you do the request, and then this one returns up.
It's,
And of course,
this is
the
what
whole thing is
profiling does.
split.
This is what profiling does. Big applications split, then inside the web, we are smaller, then it will tally up everything will tally up. So the only difference than your traditional profiling in, let's say, C profile, Python, and all that, those only count objects. Those count system objects. This count HTTP requests as well as.
They count each application includes the local code as well.
Yeah, they
So
do
each
have
layer
that.
has the code, but then if it makes a
Yeah.
call to another
Trace
service,
that.
it also traces that service.
It's like Google Maps. Like you just zoom out, you don't see the details.
Yeah.
This is like the zoomed out version.
So whereas traditional tracing and detrace, that you only get objects, and that's it. So you only know that there's a HTTP request, and that's about it. It's a difference.
Can I get the metric for this? I don't think I can. Yeah, I wanted to see if I could expand just this particular request here, but I don't think.
Yeah, I probably need to find
I
something.
don't know if you're profiling inside rack request though, because it's part of Rails. Usually, you know the performance of that. Usually, you can go inside your Rails code, like the ones that you wrote yourself. That's not part of it.
You can do that as well.
Yeah.
The library will allow you to do like, let's say that you want to profile a specific part of the code. You can like create blocks,
Yeah.
and like you just send here, and then you're gonna instead of just like so. For example, these particular blank space here, right?
Yeah, what's happening?
There is
here
something
not-
happening here that we have no clue. So we could start creating spawns here.
Can you zoom in a bit to see?
But there's nothing.
There's nothing. It's a blank space.
Oh, it's a blank space.
It's a literal blank space.
Okay.
Taylor Swift.
Uh,
No. Nobody
no,
gets that.
no, sorry.
Blank space, Taylor Swift.
It's a song.
I don't.
I don't know the lyric, but it's a song.
Yeah. So here there is like a literal blank space of, I think like 200, 300 milliseconds. No, sorry. Less.
Is it wait? Is it wait time?
It's 100 milliseconds here.
I know, is it wait? Because not everything.
I'm not sure what happened here. Like I could add things in the code
Okay.
to start sending spawns and tracing to Datadog.
Okay.
But there is something here that is not being traced that I have no clue what's going on. And this is where you can also start profiling the application itself, because you can add like your functions to here.
Someone is saying probably latency. Is it latency and connection?
Yeah, that's why I'm saying, is it the wait
No,
time?
because it's
Because-
already inside the code. You know, the
Oh,
request is already being handled. The request. So what is it waiting for?
So based on my knowledge of the application, these particular span here and this one, they should be happening in parallel. Not in parallel actually, but like in threads. So this space, it could be a CPU throttling, like one thread not being able to get and wait for.
And I guess
something
if
like
it
this.
happens like a lot, then you can take a look at it. But I guess what's important here is it shows this information that you would not have known if you were not profiling.
Yep.
Like we have a lot of ideas. People from online is also having lots of ideas, but we spark a conversation because we have that flavor.
Exactly. And that is the most important part of the talk, is because especially when you have like a very complex architecture, you start assuming a lot of things, and assuming is usually where it leads to most of the failures in approach and things, because you solve something that doesn't exist probably in a way that in a very complex way, and in the end you probably just made it worse. So if you don't have data,
You can also be very lucky and you actually get it correct.
Yeah, I
It's
mean,
the
it
probability.
does. Yes. There is that chance. It's just that I don't advise doing it.
So here's the thing, chances are that you do get many things right.
Yeah.
It's just that the ones that you don't get right, they hunt you for a long time.
For a long time.
Which is the story of our life. Which is finding a job.
Yeah, that's also true. And yeah, I think for this talk I have not have much things.
You were
in
going to
mind,
show us
so-
the nut percentage.
Wait, next question. Does it show SQL queries?
It does shows.
Sure, what?
So you can also measure and see which ones take longer.
So do you know that this actually comes from the application, or it depends on installing modules on the database?
No, you don't need to install anything.
Okay,
Because it's what I mentioned before. As long as you have so your first step is installing DB trace,
Okay.
the gem. So let me zoom this.
So we'll have to do this.
Yeah. So I mean, if you're using the conventional tools, unless you build your own, you probably won't have it here. But if you use the conventional gems that the community use, it's pretty much like out of the box. And then you get here, let's take average duration. Let me try to filter.
While you're looking for it, we have a comment. Yeah,
database.
And optimization happens without measurement. I would say,
Yeah.
Yes.
True.
yeah, yes,
Yeah,
you're
measure
optimizing blindly. You don't know what you're optimizing for. It might be the most important one.
And you can't see the results. That's the thing, right? So many times you just make a change assuming that it improves. But if you are measuring, you know that many times you make change and it doesn't actually improve. It makes it worse.
So which is why you should never make assumption when you do optimization.
And so in this case here, you're asking for the query, so I get like in this form.
So is it okay? So you actually hide the variable too.
And you can get like the average duration.
Okay.
And from here you can go and see, okay, so like if there is one query like taking like a long time, maybe you probably want to investigate that one.
So we had that, so we were using Datadog on the project as well, PJ. And one of the things that we found out when we were trying to optimize for like a lot of, because we have a lot of people accessing the application at the same time, like because there's a class and everyone just logs on at the same time using the application. And we found that through that view, the SQL query, like for certain, well, the flame graph first shows that you're spending too much time on the, or not too much, but relatively a lot of time in the database. Then you drill down into that, and we see the queries that are happening in that database section, and you'll see, okay, this is not supposed to take a long time because it's a simple select query, and then that's when you start like doing hypothesis, like is this too much of a select join? And eventually we found out because one of the columns were not indexed, and that's like, okay, cool. We'll index it, and then you have like the next bottleneck was the Rails controller itself. So you'll see the flame graph changing. Like you have a very wide database, what do you call this, graph, and then now it's like just a small spike. Then you have a lot of things happening on the controller, and then a lot of spike there. I mean, I'm saying the controller because we didn't drill down into like the particular objects or the particular code that runs inside the control. That's the point there. But we're not optimizing for that because at that point, because we were measuring, we knew that this is good enough for the effort that we expended. Like an index, once we figured it out, it was a quick hour job because we wanted to also like check and do some siege tests, and then that's it. Like we don't have to spend more because it's what do they call the economics there? The return is less. What do they call this?
It's
The differential of the return.
of
Diminishing returns. So there was diminishing returns at that point. So yeah, I wanted to fill in the time because you were looking for something.
No, yeah. So what Carlos mentioned before about having the metric doesn't only help you to find out issues, but also to validate that your change worked. So this was,
Yeah, you would think that this is a worse situation because you have a cliff, right?
yeah. So actually, this cliff here is when we changed something, and it actually improved a lot.
Yeah, I think no,
And-
because Carlos was saying this is an intuitive. Like this looks like a bad situation.
Yeah, no, but
because
this is a pretty good situation actually, because here what's happening is that for this particular problem that we had, right? We were spending like 70% on Ruby code, and we removed the gem, and we started spending like 40% on Ruby code. And what this gem was doing, it was like blocking requests. So my Ruby code was just waiting for that lock to be released so it could continue going through.
Yeah, but it doesn't. The reason this one is unintuitive is it doesn't tell you whether your application from that point where you see the clear change. It doesn't tell you if your application became faster or slower because the metric is 100% of the time, right? So
it depends on the question.
correct.
Yes.
You can see the relative time between the components, which in this case was something that they wanted to know, but it doesn't tell you whether the total request time went up or down.
Yeah, because it's the same thing here. Like because now the HTTP requests, they are taking more time because it increased from 3 to 7. But this
More
is just
time is
because another
relatively-
part, because it's a relative time. So it's just because something else got faster, and this one now takes like a relative more time.
Yes, which is why you don't look at here now.
Yep.
You look at this now. You look at your code running.
Well, is there a different view, like the total amount spent, not the percent amount spent?
Does it show?
I think it does.
Okay.
Like that, because it has all the upper left, right?
Yeah.
Percent time spent.
I think it has the absolute time. Yeah, the average time per request.
Yeah. Yes.
But where's the?
Now you
where's the-
zoomed in, so you cannot
Yeah,
see that.
Let me see the.
Is that it?
Right. Yes.
That's it, right?
Yes.
This is the clip.
Yeah, that's it.
Correct.
So everything else, well, I would expect the HTTP, the 7% thing that changed is still the same.
It's still the
That's
same.
not part of your
Yeah.
application, right?
Yeah.
Well, it is, but it's not. It's not the one that changed.
Can you show me critical failure
Failure.
on the bottom?
So if you scroll down, it's not what it is.
Okay. I just want to know what it is.
Do you have questions, Function? Sorry, we're not.
No.
No, nothing.
I just want to show the flame graph for those particular requests that they're getting logged. Because that one is actually quite interesting.
So does it show things like OS logs and all that?
Well, not by default, but if you implement a trace yourself, you probably, it's gonna show what you want.
Let's so the trend from middle of March. Okay, never mind. Later when you come back.
So let me see. Oh, I think it's too old for me to show. Let me see. I can show them. There is a screenshot from the. So that particular gem that I was mentioning is actually it's called cacheist. So this gem is let me see if there is a quick.
This was the one that was blocking.
Yeah. So this one uses Redis to lock a specific key, and it keeps like asking Redis if that key is what's the status of that key. So when you
and
see
it
on
shows
the
it here.
yeah.
It keeps on
So
asking.
it keeps messaging Redis, and you were like, what the hell is going on here? Like why does it keep like bombarding Redis on the? So we trace down like all the way on the library. And
Okay, this is a very stupid library, but okay.
But you wouldn't have known because it's not obvious. That,
Yep.
Yeah.
I mean, it does its job.
Yeah, it does its job in words, but it's stupid. There's implementation.
Yeah, it works, and it was pretty weird to
I think it's the relationship of the gem design and the way that they use it in the code that causes the problem.
Okay.
I think in a more traditional, if you didn't have that many requests in parallel for a multitude of keys, then it would be more efficient with the lock. But the way that they use it, it's not.
and in the end we didn't actually have any benefit on the lock, because there wasn't like any critical there was no critical implication of letting like two requests go through. So we just like removed them. But that's how profiling also helped here.
Awesome.
Yeah. If Ryan has anything to add, but that's everything I had planned.
Nothing from me.
Sorry, what did you say?
She said there's nothing from her side.
How much do you pay for each year?
I don't know. I don't pay. My client pays.
Pay for what?
Client expense. So I don't know how I pay
For
for
what?
how much they.
Data I don't remember.
Unfortunately, I can use these, but also decide on the budget.
I particularly like the way Datadog does the visualization.
I know.
You can, I used to collect metrics from StatsD in a lot, but then visualizing the data was not nice. But if you start sending the metrics that you collect to Datadog, their visualization is really good.
Yeah, that was useful for us as well because it's not just the DD trace agent. You can have other sources of data and it goes to Datadog, so you can correlate.
So when I used it, I didn't use any of their integration. I was sending the metric. I had an application, we sent the metrics and we used to collect it, and the tools that we used were not great. And I was like, okay, you know what, let me just send the data to Datadog, and then we use their visualization, and it's really good.
Yeah. Good. Do you have anything for us?
I guess for profiling, what I use is I think I use Grafana.
Grafana. But so that means you use your own, you program your own visualization.
Not
Yep.
really.
It's not really I would say that good because you need to do everything by yourself. We did put APM and stuff like that, but yeah, a lot of work. Actually, that's a lot of work to do that.
Yeah.
Does Datadog have a free plan?
I don't
I
think
think it does,
so.
right?
We host ourselves for data doc. Yes, there's a free plan. Yeah.
I used to use a service.
We're not sponsored by Datadog, but we just use it a lot. I'm sure there are. I think the classic one from before starts with an N. I forgot the one that was popular for Rails people.
So we
Skylight. Skylight, yeah, the Skylight. But there was the progenitor of all of this, like the original one, in something.
Datadog gives you a free plan, but the data retention is...
New Relic, yes, New Relic, sorry.
Datadog has a free plan, but the data retention is for just the data.
So that's one there.
Yeah,
It's fine.
it's
It's
more
That's
like-
fine. Yeah,
It's for a trial, so
Yeah.
you wanna see how the service works and how.
for an emergency. I have an emergency now. I do Datadog check. Yeah, the New Relic RPM stuff. I think that started in 2011, 12. It was probably before. That's when I first heard of it. And then Skyline and Datadog, all of these things. It's just that New Relic is so expensive.
Yeah, New Relic used to be really expensive. I don't know if it's still the case, but it used to be really expensive.
Yeah, it is. But I'm old school. I'm using whatever operating system we have, like Stat. Okay, I can see profile.
So I can probably do Grafana and StatsD and all of these things if like cost was very much a thing, but for like, it really depends because you spend a lot of time configuring Grafana and StatsD to show the important things, whereas
Not
Datadog
really.
already has everything.
Not really, because I managed to get my interns to do it, and it don't know that.
Yeah, but still it takes time, right?
No,
This one
it takes
is-
like 1 week or so.
Yeah, exactly 1 week. This is like you just need it now.
There are good open source tooling nowadays.
Yeah.
So if you go for if you want to run something like InfluxDB, like
Yeah.
the tick stack is a very easy one to run.
Correct.
And then you also have gems and that integrates with most frameworks that will give you.
And-
It's not as polished as using a commercial service, but it's good.
And I think we explored something where the Datadog agent, it basically reverse engineered the payload of the Datadog agent, and you can configure it so it receives the data from the Datadog agent, and then you just parse it on.
But you do get what you pay for, because put it this way, not who knows how to monitor this kind of system at deep level currently. So you need people, so it's very easy for you to have enough experience, but you do not need to have too deep of a system knowledge to configure this kind of thing. So and that's a lot of the value there.
Okay. We'll go to the next one, which is not this window, this one. Protocol buffers, and I'll be doing it. Who has heard of protocol buffers?
Never heard of it.
I have.
You have?
I have reverse engineered
Yes.
a software that used protocol buffers, and once I managed to steal their protocol buffers, was like, it was magical.
Yeah. So it was the same thing. So
Just-
my,
yeah.
my journey with protocol buffers was similar to, I guess, to yours. So I'll close this, and because I am just going to use my thing. So this was like when the pandemic first started, and like, okay, I can't go out, I have nothing to do, and then I found this place called Manga Plus. In case you,
We're also not sponsored by Manga Plus.
yes. So Shueisha is by, I think, this media or something. It's a publisher that translates manga from Japan into English. It's all free. Well, not all free, but their business model, they don't have a business model right now. They're asking, basically, they're asking it how much should you charge for a subscription, etc. What kind of model. Their parent or partner or something, Viz Media, similar to this, but what happens is you pay a subscription, you get 100 chapters to access for free. Because what happens is, for example, if you go to, let's say this one, it's a popular manga. You have the first 3 for free, then the last 3 for free. So it's like streaming, right? Or like TV or something, right? You have to watch it there, or you have to read it on the day it comes out, and you have like what? I think this comes out every week, so you have 3 weeks to make sure you read it. Otherwise, you can't read it anymore. And that was my problem because during the pandemic, you lose track of time. I forget, oh, I have a manga that I wanted to read. This is all web-based. I'm sure I can just go and download the thing on a weekly basis because this is not the only manga, right? You have a lot of them. Like you can scrape them, download them, and those things, right? And then when on the weekend when I have like more time, I remember, oh yeah, I have to catch up on these literature. Then then I can just like read all of them and then compile them. And that's how it was. And from what you see here is one of the network output that I saw, and so people who have worked at protocol buffers would probably have seen this. In the beginning, I thought, what is this? And this is a binary format.
Yes.
You have this, and like, what is all of these things? Like, what? I don't know how to parse these things, right? And then, of course, looking at the JavaScript source code, etc., and they started talking about protobuf and those things you Google around. Eventually, I ended up reverse engineering like the proto buffer, the proto file. We'll go more into those things later. But it's not perfect. But I don't need it to be perfect. I just need to be able to get the actual image, right? So I wrote a gem that so you can go to Perisquid, GitHub, Perisquid/manga_plus-API. And you have this, so it's a gem that basically implements the Manga Plus API through the protocol buffer. And one thing though, so I already forgot how I did that, but you'll see, for example, that the JPEG, this JPEG is not the JPEG itself. This is actually encrypted and all of these things. It has a key and all of that. So the gem handles all of that as well. So I'll show you quickly how it works. I wrote an example program. So what it does is, it requires the gem. Let me make it larger. This. Yes. So it really,
You're sharing the camera on the screen.
am I? Oh, okay.
Yeah, I'm not sharing your.
Sorry. Gui, what are you doing? Why are you not? I need to share the whole screen. Sorry. There is, now people can see what I'm showing. But at least they saw whatever is
Now
on
they
the
can
screen.
see the quick look at the protocol offers the presentation.
No, I have to use this.
Back
There.
camera.
Right? Okay.
No, we're seeing it out.
Are you on YouTube?
Yeah.
Oh, this is delayed. So this is already so
Okay, now I see your.
so Shueisha is Shonen Jump. Yes. Okay. Sorry. Here. Okay. Maximize. So there you go. So you'll see that this is not the image, and the key is there, and then there's some sort of like encryption. So we'll go to the code. This is already using it. I'm not going to show the whole how it gets encrypted. It has like I already forgot how to explain it. Like I was looking at like things. It's a big binary XOR something. But you require it. I just include it so that it looks okay when you. Otherwise, it's a very Go-like thing. So it's very long. Title detail view, for example, because there's the same name in the proto that they're using in JavaScript. So I'm just replicating it in the Ruby version. You get it? You get all of the titles. You select one at random. You create a folder. You download it, and then for each of the items in that particular list, because all of the payload will give you the list of URLs as well, and you just basically get through. You decode the image, you save the image, and then you do it. So let's try running that. I have on the README, so you don't need to have Ruby installed, you just do Docker. Yay. I think I downloaded it, it's fine. Download it again. So we run the thing, and you see it goes out. It shows dry can something. It's downloading things, and then you'll see that it has manga here. Right. So you have now it's downloading things. I have a more advanced version of this that is on a private repo that I'm not sharing, using this gem that downloads almost everything. Zips it, renames it as CDZ, and then so now you have like proper categorization of these things because they have tags as well. So this is just an example. But yeah, that's it only downloads chapter 1, which is always free. So it's a good example. And so that's how I got introduced into protocol buffers, like through this manga application. And while we were looking for like talks here, I thought like I remember this, like is it possible for us to use this as a payload instead of JSON? Because that would have been like this could have been something that the payload could have been something with JSON instead, right? Why are they using protocol buffers? Because that time I didn't care about the why. I just wanted to have this work because it's very purpose driven. So now I got like to think about why would you use protocol buffers and how would you use protocol buffers in a Rails application. So I did a small application. Let's go to this. This is a repo that I did in preparation of this talk. I'll go to the first one because this is the initial commit. This is a mono repo with 4 folders. You have API, which is the Rails application. It's a Rails new dash APIs. It's a Rails without the views, basically. And you have something called, I'll just open it on this code, I think it's faster. You have API, you have web, which is a front-end application in Vue.js. You have iOS and Android, and then of course Common. Common is where I'm putting all of the non-proto stuff and the generators to auto-generate code based on that. So we've been talking about proto, right? What is proto? What protocol buffers does, it's similar to a concept called schema-driven design. So everything starts from the schema, which is codified in the proto file. It's called the proto file because the extension is .proto. And we have this, right? What? So what is a proto file? It basically describes the schema of your payload. So you have messages and you have things inside the messages. In this case, I have 3 messages that I want to do. So this application, by the way, is the classic Rails application in the Getting Started guide. You have an article and you have comments on those articles. And you have 3 messages, basically the article list, the index of the articles. You have an article, you have a title, body, and list of comments. And then your comment is has a reference to article ID, a commenter, and a body. I did not implement the rest of like the lead update and all of these things because that's like too much work. I just wanted to show like how this actually works. But this is the gist of a proto file, right? And then you have this. So you can think of it as a typed payload. And the thing, and what's great about it, you can see, for example, here, Gen PB Ruby, right? This creates, so from the proto file, you create the code that encodes, decodes, creates messages, etc. from the proto file. And Google Protocol Buffers has CLI tools to automatically generate it. Basically, you don't want to hand code your own message parsing, the code, etc.
It's like the ORM.
Not really, because even the ORM, it's already there. From the proto file, it's generated, so it's code generation.
It's more like a contract kind of. So if you have used like Avro, it works similar to that.
Okay.
You don't change. It's like resolve.conf that's being managed by. I don't know if they're
I know that one. I understand.
like your network manager. So you don't touch the generated code. You can inspect it, you can see what it does, but every time you want to make a change, you don't change the code, you change the profile. So in this case, it's on the build Ruby folder. We have this. It's very opaque. I don't know what's happening here. You can probably guess, but you're all interested in is this part, because you have proto, colon, articles as your proto is the namespace, and then you have articles as the class, article, and comment. And you can, and it becomes more clear. For example, if you go to this is my API. For example, you have proto, articles. So I like this is Rails 7. Their IRB, their Rails console now has like all of these auto completion. It's quite when I first tried it, I haven't been writing Rails for a long time. This is new. Okay. But you'll see, for example, you have articles, right? And then you have all of the things. This was because of that code from before. You don't change that. In fact, the way I did it is where did I? So you'll see that this is just a sim link into that. Because every time I change something, for example, I want to change the proto file. Let's say I put a new, what do you call this? A new field, like string test. The 1, 2 is just the order, because payloads are ordered. It's typed, and your fields are ordered. Because again, it's a binary format, and so you pack things. And so Google is recommending that you don't think too much about how it fits. Like usually, because if you're dealing with binary formats and packing, you want to pack it in an optimized way, right? But they say don't think about that too much, because it's a payload. Whatever makes sense is the most important one. But of course, you can do that too. You can pack things, but it's not the important bit that people insist on. So you do that, and what you do is, I've already created a little script, so I can share. So gen Ruby, and you'll see that this has changed. Now it has this particular line. So if I go, for example, to models DB Ruby, you see that there it added something. That's why you never change the output. You always compile. And why am I compiling the Ruby code? Why am I doing the compilation in the first place? It's because we start off from this, and all other applications, which is why you have all of that. It shows that you can compile for iOS, Android, or Objective-C, for Java, and for JavaScript, and in this case for Ruby. And if you have other languages as well, you compile for that. And the benefit for this schema-driven design is that when you change something, you change the schema, the other code that depends on the payload being correct in terms of schema, they don't have to care and change their code manually, because all of the code that refers or interacts with the schema or the payload is going to change. And of course, you build it, you can automate it, of course, but you don't have to encounter that problem where, oh, the backend changed their schema, now the front end is broken. That mostly won't happen, because when you change your backend, that's because the proto file changed. The proto file compiles the front end, the backend. The front end people will notice, okay, the proto file has changed, and probably through a continuous integration, compile the new thing, and then everything is going. And you can, your build system will probably fail, because now it's calling different fields or different methods of the object. And so that kind of commonality ensures that everyone is working on the same schema. Again, this is by Google, which is a very large, sprawling company, and this is a solution that they proposed in order for that, because they have a lot of a lot of systems that need to work on the same schema. Right. So what is needed?
Question: does it provide backwards compatibility?
That's part of the protocol buffer. This is so there are no versioning, but the what do you call this? The best practice here is that you never remove fields.
Mm.
If you need to add fields, you need to rename a field, you add a new field. And so basically all payloads are backwards compatible with others. Because if there's an extra field, the parser or whoever is receiving the message automatically ignores the extra fields.
Okay.
That's why you never rename or you never delete. You always add on to it. So like longer, if you want to be backwards compatible, the longer your application is, the more what do you call this? The more then fields you have on top. It's a very Java-like thing where you maintain, or Go maybe, then you always maintain backwards compatibility, and you add in a lot of cruft. Of course, you can version your payloads so that you confirm that maybe in the first iteration you deprecate, so basically you give a warning, and yeah, you have that fields, and then next version, you just payloads just are not compatible with each other. So that can be a valid strategy as well. Right. So how does it look like if you're adding it to a REST application? You've seen it, right? So this one is the initial commit. You don't need this.
You were going to show something on the console, but then you moved.
Did I? What was I going to
I
show?
don't know. You started typing something. You said, "I like this because I can do this," and then you.
Yeah, I just compiled a.
No. You were using the generated model. Didn't you have a terminal open where you were showing like how to use the generated model? You comment on the completion and stuff.
You're talking about Rails also.
Yeah, but you use.
I just showed I just showed the methods that were created by the generated code, like decode, encode, minimization, and yeah, those things. So let's go to this basic CRUD. Yeah. So if you want to do it in your Rails application, there are a few things that you need to do. First, of course, I added course because the front-end application is on a different port, the back-end is on a different port, they just don't talk to each other. Well, they talk to each other, but the browser will stop you unless you have proper course thing. So if you're getting this as a reference for Google Protocol buffers, don't copy it because the course setup is very permissive. And I do not take any responsibility for breaking your security model. But that's it, right? Yeah, so this is a normal CRUD application. This is a Rails API, so everything is in JSON. Document controller, the article. Again, the classic, what do you call this? The classic getting started guide. This is the course setup that you should not copy. And the routes, that's it. And then I have just like a small seed file that generates some seed data because I did not implement the front end for the create, delete, and all of those things. Actually, I did finish the JavaScript portion, but I will tell you what I would have done if I had time. Yeah, but I did finish the what they call this, the Rails portion. So this is the actual part where you where you what do you call this? Include protocol buffers. Like instead of just JSON, I want protocol buffers as a payload. And the reason why you want JSON is because one of the disadvantages of protocol buffers is that it's not human readable, right? Like you can't do exploratory API checks. So it's not a good experience for developers. You can't curl and then you immediately have the result. So you want to have JSON as well, and then you have proto files for the actual machine-to-machine communication.
In the bright side, you're going to prevent all the developers from discovering your API as well.
Yeah, not really.
Not really, but I mean, you add one.
Just like it's not.
Yeah, just.
Or what you can do here is you can always switch if the environment is in development, then allow JSON, right? But in this case, you'll notice as well that GitHub does not show the generated files. You saw what MongoDB.rb was, right? It's
How does it show? If you do the load.
It shows exactly the same file, like the thing. But this is the point. Even GitHub recognizes that this is not something you should care about.
Okay.
You don't care about this. It's code, but you don't care about this. You want to just use it. And the API is the same. Like you can code the code, you can generate things. It's not the important part. That's why even in the diff, it doesn't show. It's a confirmation by GitHub. Don't care about the output. Yes, this is the. So I'm using protobuf JS. It has a command line interface, but just like everything else in JavaScript, you have multiple ways to do things. I don't know if this is the best way. It's just one of the more popular ones. For some reason, more popular than the actual Google Proto C output. I have no idea why, but that's how it is. So that's
JavaScript developers, you don't question.
Yeah.
Trust me.
Yeah, don't question them. Just accept that.
Ruby is a first-class citizen in protocol buffers. The Proto C, the official Google Proto C, supports generation of Ruby code. JavaScript is, I think, in beta or something. It's not officially supported yet by. This is the protocol, right? And that's how you add it. Now, the definitions for. Wait, am I not connected? Okay, so I'm not sure what's not showing. Okay, so the first thing that you need to do for on changing your Rails application to support protocol buffers is set a MIME type for protobuf, right? Because you want .proto and then you want it to reply with your header as a proper MIME type. Protocol buffers doesn't have a standard for the MIME type, so I just use x-protobuf, application x-protobuf. The thing is, Rails API, if you use Rails API, a lot of the middleware is not enabled, which is why you have to include the MIME response. If you're using Rails API, it just expects everything to be JSON as a MIME type. There are no other MIME types except that. So you have to do the MIME response so that you can do respond to, and then you can do the format thing. Speaking of the response to, that's how I chose to do it. So you have your articles, and then you can respond to JSON. So before it was like this, right? Like everything is rendered JSON, and you want to add on to that, and you want to also do format.proto, and then you render a proto file, and you render plain because for some reason I couldn't do a render the proto as a MIME type. It does not play well. It does not actually give output. But plain will render everything as a binary, what do you call this? Binary string. Again, that works. So you saw as-proto. As-proto is not part of the generated code. That's actually part of the model that I created. And so I created an as-proto instance method. All it does is automatically encodes, because I need to debug as well. If encode is true, then it creates anything that has the namespace proto was automatically generated by the protobuf. Article encode, and then article.new entry. So this is the object, and this encodes it as a binary string. And this is exactly the thing. The as-proto, the result of this is the string that was set.
So essentially, those JSON is equivalent to the field. We just put the value within and generate the value for it.
Something like that.
Yeah. Okay.
I'm not sure if it is comparable to JSON. It's just that, and I'll get back to like
It's the
way
way
they
we
use things.
essentially in protobuf format. Native
It's,
protobuf.
yeah, it's a serialization format. You serialize it into protobuffers.
Okay.
This one is the encode true or something is just like for debugging. It's also because I have a collection, and you cannot encode, like it's not good to encode protobuffers into a protobuffer. So I just want to include you want to encode objects to the protobuffer, so you don't actually encode a thing. So you have a collection, and it just like goes through everything, and then it encodes the whole object. Okay. Same with comments. You have an as-proto, and then you have the matching, and then when you put it through a false. Okay. And then you saw the MIME type before, so you just register the MIME type as application next to the buffer as proto, so that you can use format.proto as the response to it. So let's take a look at that. We go to API, Rails S. Let's do a split screen. Then I want to go local host 1000/1 So this is JSON because the default is JSON, but if I go to articles1.proto, you'll see there's nothing, and then so this is a binary format. It probably looks better if I give you the index because there's more. Oops, there's more to show, and then you'll see like mistakes, right? This is ASCII. So the reason why is because it's the first record, and the first in binary null is does not display anything. So this is now encoded, but you'll see it does not encode the actual context. And this is one of the ways you would want to think about if you're going to use JSON or you're going to use protocol buffers. Like, why would you use protocol buffers if the contexts are not encoded anyway? And the point is, it's not supposed to replace JSON for all cases. Right? In this case, if it's all mostly like, let's say, blobs, right? You have one key, and then you have huge text, and then another key, and then a collection of comments which are also huge text. You might as well just turn on gzip on your web server so that the browser will unzip it, and then you have better compression. If compression is what you're looking for, this is not the thing. It's not used for compression. What it is great for is for something like Datadog payloads. Let's say you have that kind of information. You have a key, and then you have like some data, and then you have a collection of that. That can be much smaller than JSON because your keys you don't have to do single letter keys basically in JSON if you were going to do it yourself. Okay. You can have readable parsers and readable message creators, and then on the wire it's still going to be smaller. One application there as well is something like Hivekind for the wire. Where is that? Have you heard of Hivekind? Have you heard of Action Cable? The Action Cable, any cable is a replacement for Action Cable, so that it does not, it can run separate from Action Cable, and you're not tied to just using Rails. You can use any other. So it's using the infrastructure, the message format, and all of these things, so that you can run that kind of RPC, but separate from running Action Cable. So cable, turn it off. So it only works on the Pro version, but you'll see here, for example, that you can use protobufs or another serialization called message buff, so that you can serialize and serialize things faster. Because this is RPC. You just send lots of instructions onto like usually enums or those things. It's very, very good to pack that into like binary messages. Because there's no human readable text there anyway. So that's the best use case of protocol buffers in that sense. You don't want to use it for like huge formats, like mostly text, but you want to use it for objects, for messaging, RPC. Well, RPC mostly deals with objects, and you serialize it, and then you push it over the line. Those things. Okay, yeah, it is a great look.
You mentioned that JSON as one of the comparisons. You mentioned the compression, but the thing is not only the wire, the size of the wire. It's like generating like encoding and decoding JSON stems low.
Yes, that is also one thing. Although in the example, if you have a key and a huge text, that's not allowed to decode, right? But if you have like higher keys of like
The
object
serialization of objects in this serialization
Correct.
is very slow for doing JSON.
Correct. And it's not a complete replacement of JSON for all use cases. Sometimes you would be like, it's just better to use JSON. But yeah, for those use cases, this is the reason why you would use protocol buffers. And of course, the other reason is that your front ends, your mobile devices, iOS, Android, your JavaScript applications, they don't need to like keep on like, testing the endpoint or like going to Confluence and then checking what is the latest schema. The schema is encoded and the code is auto-generated. So I'll take a look I'll quickly show you the application that I did not finish. Where is it? Here. So it's just a small Rails application and it's in article index view. So this is just how do you say it? A Vue.js. You'll see it's a single file component, no template, no styles. You have a script. I was trying to finish it without Proto, but right now it's just going to run as let's do it as in JSON first. So, web, run dev. Let's go to 5.3. So this is just the getting started of Vue.js. You have all of the articles. I did not put the comments. I was supposed to go there and then you see the comments. This is reading the JSON. And of course, the next thing there is to convert this to read the proto, but it's not that difficult. If anyone is interested, I can finish this off like with it in the weekend, and then I'll publish it on GitHub. But basically, what's going to happen here is that because this is your call, you just change it to .proto, and then instead of immediately assigning it to data because it's JSON, you decode it using the protobuf package, and then you assign the JSON deserialized object into our data, and that's it. But yeah, I'll finish that one. Do we have any more questions? No question. Yeah.
So is there a proto gem in the Rails application?
Yes, there is a proto gem. I think I showed it quickly on the diff. Extra gems here is called Google Protobuf.
Right.
And we have documentation and the full.
So it has a native implementation.
I don't know if it's native, but it's from Google. Google. So this is the source code, and then these are all of the supported languages. We go to Ruby, and then this is the source of that gem. So they also have a mono repo in this case. All of the languages that are immediately supported are here, and you notice JavaScript is not here because it's not officially supported yet.
Why not?
Well, it's primarily used internally. Originally, it is
There's a lot
internally for RPC type of use cases.
No, well, there's a lot of like I said, JavaScript protobuf implementations, just not from Google.
Yeah, when Google use it, they don't have that.
Like for example, Go is not here because Go has its own implementation. So it's not part of this repo.
So the community made their own better one,
We
maybe.
don't know. Yeah, there is a proto C for JavaScript in one of their data. I forgot where I saw it, but it's different from the output of the community developed one. But I don't know. I think there's more tutorials and there's more information for the community one rather than the official Google one. Yes. And you'll see, and then one of the things that I experimented on here is like also doing mono repos, and mono repos are actually quite good too. Like, I can see how it can scale. Because when you change something, it's like you know how things are connected. Everything is in one.
You have a single state,
Yeah.
so even if you have like multiple projects, people are working on separate units, but the things that you care about are always in a single state. You check out one project, that's it.
And it's because it's not just a state, but it's a logical grouping of application. Like you can say, yeah, your front-end application is one application, you have your iOS application, Android application, but from a certain point of view, that is your whole ecosystem. You want a single view. If one changes, like your proto file changes, it affects everything, then that is something that you want to see.
Right, so every time you look at something like all if you have something that includes a change in 2 or 3, you always have that one state that has everything together. You don't need to like, oh, this version of this with that version of that, and then here's a reference to the correct one.
And every time, and the advantage there as well is every merge into master, if you're doing that workflow, because you want to always keep master passive, right? And every merge is always like a change set that probably satisfies like a story or something, or a feature that you're tracking, and it passes because you have all of the tests running on that thing. So it's I can see why that kind of workflow scales. Even though you have lots of applications inside, you don't have to touch everything anyway. We have questions on chat. Sorry, I'll put that. Well, that's it for my presentation. Sorry, it's I didn't finish it because I had to do the pizza. I had to do the setup of all of these things. But I will see if we have questions on our chat. What does it compress more effectively? Sorry, let me show the this one. StreamYard. This. Yes. No, I shouldn't be sharing screen.
Yeah, you should not.
Yes. Okay. Gui, are you okay?
Photograph is not from
All right. What does it compress more effectively than JSON? Assets like media and hashes. If you have something like objects, like for example, you have a key and then you have an enum, for example, like an instruction. And in the code, it's represented as an enum, like a push, pull, or let's say a stack operation, a push and a pop. And it can easily be compressed like, okay, your RPC command is going to be like 1, and then your actual value will be like 1 and 2. That's generally how it will be represented in the protocol softwares. Whereas in JSON, then you probably have the whole key, command, and then you have push or pop, and those things. So that's how you would think about it. It's not really compressive, but more like a representation. And there's a more efficient representation of things. If you're representing text, then that's how you represent it, right? There's no other way to represent text except the actual text. But if you're representing logical things, like push, pop, or like something else, then or reset, then you can do it like as a 1, 2, and 3, and then you have a logical mapping to the actual operation. Does it add a layer encryption over the assets? Yeah, it's just not human readable. And you usually, to make sense of what that field actually should be, at least what the developer intended it to be, or to parse it, then you need the proto file. But it's easy to reverse engineer, especially if you have the source, because like you said, like you saw, right? Title detail view is being used in the JavaScript source everywhere if you're referencing this particular data structure. So the proto file must have been called title detail view, because the auto generator will generate those kinds of calls as well. Like the field name is like some sort of transformation of the actual field in the proto file, and that's the method that you're calling. All right, Gui, do you have anything for us?
I think protobuf, I previously used it in Java before. So it's, I think binary will be a good description of it, because it's if you compare binary versus text, text will take up because it's characters, right? If you use binary, it will be much more smaller and faster. Yeah, it's depends what use case you want to use it. But yeah, JSON is fine, I guess. For most part.
Also, yeah, JSON I think is mostly fine for a lot of things.
Yeah.
But if you know your use case, if you want to use protocol buffers, if you have lots of RPC, lots of small objects being shuffled back and forth a lot, over and over, then you want a smaller serialization. Think about it as serialization rather than compression of a payload. All right, I think that is it for us. Let me see if I can share the presentation. Share screen. Window, this one, share. Okay. Put that on the screen. All right. That is our little protocol buffers. I don't know what we put in parking lot. I forgot. Probably nothing. Like maybe announcements. Announcements is November. The next one. The next will be Tuesday. Is on October 4th. I think. 4th of October. Tonight is at 1 a.m. is the Apple announcement. If you're interested, they said they're announcing things.
What Apple announcement?
iPhone.
iPhone 14, new iPad, the Mac Pro, and 2 and 1 or whatever. If you're interested,
Yeah, that's
Tonight.
actually different.
WWDC.
the keynote, WWDC. Is it WWDC?
Yeah,
No.
WWDC.
Yeah.
I don't follow.
Welcome to the club. I use Windows.
Well, now we have to because a lot of our applicants are using M1 and Vagrant doesn't work on that. So we have to. We said that we're going to be tackling it when we have more people asking for it. So we need to spend time on it.
So what we actually do is we use Docker because that is thankfully supported. So then we just under our toolkit.
Well, yeah. So that's why I'm looking to it. But yeah. So that's it for our announcements. Gui, do we have any other things?
Go to the JavaScript meetup tomorrow.
Oh yeah, there's a JavaScript meetup tomorrow. If you want to know about calendar of activities of things happening, you can go to devcami.com/meetup. And
There's PyCon next week, but then
Python, if you're into Python, I don't know, you might just want to do hopping, technology hopping.
Where's the JavaScript meetup?
It's actually at EcoCity. It's DFK. It's at EcoCity. So it's one station before this. Just walk across. It's on the map. So just find DFK. It's one of the.
We can go to devcami.com/meetup. You can go there. You can find out.
I forget to add it.
Okay, but anyway, you'll add it tonight and then function can go.
I'm going to set up my watch.
Is there a return? No. No! Why? We don't have a return? Yeah, we have a return. Meetups. Okay, there you go. We have, Ruby Tuesday.
Yeah.
Apparently, no. Okay, yeah. JS is not there,
I will add it up.
but it will be there.
There's
If you're interested in Rust, it's happening next week. 14.
The guys is fun.
Yeah.
I like Rust the language. I'm just saying that the guy is also fun.
Is there Elixir?
Huh?
Is there Elixir?
Elixir, I don't know what happened to Elixir, guys. Those exist. I know those exist.
Well, I can organize it.
There
We
was,
just need
No, there is
there wasn't
a-
enough. It just that
I do not know what happened with the people.
after the pandemic, I did not hear.
Yeah. Yeah, correct.
Okay, so after that, we have some hiring shoutouts. Who's hiring?
Not me.
Mind
Even
Valley.
though some people are leaving your company.
The figure.
Mind Valley is hiring.
Mind Valley is hiring Ruby developers.
Elixir.
Why are you leaving? Elixir developers, so that's online. If anyone of you wants to switch to Elixir, then sure. Rep. Who else? Hivekind?
Yeah.
Hivekind is hiring hivekind.com/careers.
Ruby developers specifically?
No. I think those should show the. You have your pages. Hivekind.com/careers. We have JavaScript developers, Ruby on Rails projects, and software engineer with DevOps experience. It's Hivekind.com/careers. No, Vision is going to haunt me again at YouTube. I already like it. He has already tapered off, but he's going to come back. So, where's this? Where do I find? Is it on Join Us? Positions, yeah, okay.
Yeah.
I guess technology.
Yeah.
Okay, so you have CTO, information security, Android front end, which technology? React, Vue.js,
View currently.
iOS, Elixir, platform engineering, Elixir, and Elixir. So go to mindvalley.com's, what is this? Careers@mindvalley.com/positions, or you can go to careers, hivekind.com/careers for those things. I just realized I'm not I'm not sharing the screen.
Nice.
No, we're not. Yeah, Goy, you should mention if you're not seeing whatever I am sharing.
Yeah, because I'm not sure whether you show it just on that screen or slides.
Share again. And I will repeat what I just said. Hivekind.com/careers. These three so far, at least at this point. Careers.mindvalley.com/positions. Everything that I just said last minute ago. So those are hiring shoutouts. Okay, and what else do we have? Yes, see you all in October. That's it. We have pizza, as you can see here.
Photos will be out on Friday. For you guys, what they're not into that.
So we are starting. This is going to be again online, and then in person, hybrid, and recorded on YouTube. So it's not only hybrid in terms of space; it's hybrid in terms of time.
I just got it.
What is this? Okay, well, that's the end of the meetup. We're just going to continue on, but feel free to drop off if you are interested. Gui, any last words for us, or are we good?
Yep, I guess see you everyone in Facebook and Slack. So yeah, do join those two channels. Most of us.
Slack, Ruby, what is this? RubyBrigade.my/Slack or something. I'll put it here. I hope I'm sharing my screen again.
And join Engineers My,
Go to engineers.my,
join our Discord and find the role.
join the Slack community. You click on that, you get to join, and then we can advertise you on yeah. So Ruby Brigade. You probably should just change name to Ruby Brigade Malaysia. So Ruby Brigade.my redirects to the Facebook group. And that's it. Yeah. Okay. Bye everyone. See you in October.
Yeah. Thanks.
See you. I'll end the broadcast. Yes.
Just holding this.